Hey guys, welcome back to Data Products. In this video we're going to be doing facet plots. And so what a facet plot is it's a way to take multiple plots and put them into one figure, if that makes sense. So if you ever read a paper where you have like one figure and it says, you know, panel A, panel B, panel C, panel D, etc. That's what we're going to make today. You don't have to do it in PowerPoint. We can do it straight in R and make some nice looking graphs. So with that, let's get started. Alright, first things first, open up your RStudio. And now let's make an HTML file, our markdown, Facet Plots. Alright. Okay, so first things first, let's look at how to put multiple plots together into a single figure. Alright, so let's load our package. So we're going to need a package called ggpub.r, and of course we need ggplot2, theme set. Let's get our theme all going here. Use what you want. I'm going to use black and white, and theme, legend, position, I'm going to say top for mine. Alright, let's run this guy, good. Alright, first let's create a nice box plot. So we're going to do data frame is tooth growth, of course, and then set it as a factor for dose. Alright, so we load our data and create, let's annotate this. Let's load the data and create the plot object. Alright, P for plot, ggplot, data frame. Our aesthetic is x equals dose, y equals length, and then geom box plot, aesthetic, fill equals supplement, so they're different colors by supplement, position equals position dodge 0.9, and scale fill manual, so we'll pick our colors, values equals collection. I'm going to do 00AFBB, whoops, make that 00, not 00, and E7B800, and then we'll print P. Alright, so that's our nice box plot. Now let's look at the ggplot facet function. So one thing you can do is facet grid, and you can move things around. So I'll say rows equals variables of supplement. So if I run this, you can see that my rows are the supplement. Alright, so instead of having it divided by 0.5, 1, and 2, instead, well, it is divided by 0.1, 0.5, or 1 and 2, but instead we have each row we've isolated where our supplement is, orange juice versus VC. Alright, now let's do a facet with multiple variables. Alright, so, oops, keep keep that lowercase. P and facet grid, oops, underscore grid. Rows equals vars dos. And then cols equals vars sub. And then let's print that out. So as you can see, that ends up putting it in the same orientation. So this is our default where we have rows equals dos and cols equals supplement. All right. Now let's look at the facet wrap function. This allows facets to be placed side by side. P and facet wrap. Oops. Man, oh man. Vars dos. Number of columns equals 2. So you can see here, we're saying we want a facet wrap, so each one of our doses is its own facet, and we want 2 columns. So if we change this to 3, you can see it puts them side by side by side. Or if you have 2, you get this, and if you change it to 1, they'll all be stacked on top of each other. So we'll keep it at 2. Okay, now how do we combine multiple plots using GG arrange? Let's start by making some basic plots. First, we will define a color palette. And data. Man, oh man. Okay. So let's do my 3 cols. It's going to be a collection of E's. You can pick whatever colors you want here. B800, 2E9FDF. Hopefully these look good. FC4E07. Okay, then did we already set dos as factor? Oh no, we want to do. I've learned my lesson from changing code on the fly. So I'm just going to redo this command. So tooth growth dos is as factor tooth growth dos. In one of my previous videos, I said that I spent a long time recording the video and I couldn't get it to work, and it's because I was making edits on the fly. So now let's make some basic plots. So if you ever record videos, just stick to your script that you've gone through and troubleshot before. Alright, basic plots. P, our plot is GG plots. Tooth growth. Aesthetic is going to be x equals dos, y equals length. BXP, so our box plot, is going to be P and geom box plot. Our aesthetic is going to be color equals dos, not supplement dos. And then scale, color, manual, we're going to pick our color, and then So now that we've saved our colors in that variable, my 3 colors, what I can do is I can say my values equals my 3 colors. And I think that's it. And so if I run this, plus. Okay, so it's not going to print because we didn't call it to print. So, but we've saved it, so we're going to add it to our facets. Okay, now let's do a dot plot. So we can do dot plot equals p and geom dot plot. Aesthetic color equals dose. Fill equals dose. And then bin axis equals y. Stack dir equals center. So we went all over this when we did the dot plot. Scale color manual. Values equals my 3 colors. And scale fill manual. Values equals my 3 colors. All right, so we can run this one. So we got our box plot, which is P, our dot plot, which is DP. Now lastly, let's create a line plot. All right, so LP for line plot is ggplot, and we're going to use the economics data, even though it doesn't make sense, but we need something that makes sense as a line plot, and the tooth growth data is going to look terrible as a line plot, and we're just going to mix and match just to show you what a good line plot looks like. So geom line, we're going to say Indian red. Okay. All right. Now we can make the figure. Oops. Probably should put this in an archuk, huh? All right. Figure is GG arrange. Blocks BXP block for box plot. DP for dot plot. LP for line plot. Labels equals a collection of A, B, C, just like you would do C in a paper. Ncol equals 2, and row equals 2, and then figure. Okay, so let's see what we got. I hope it works. Oh yes, perfect. Okay, so as you can see here, we have our figure A. We called our labels A, B, and C. Our first one here, we have our dot plot. Our second one here, we have our box plot. Or sorry, first we have our box plot, second we have our dot plot, and then we have our line plot, which is the economic data. It doesn't make sense in terms of giving this to somebody to, you know, make sense of, of your data. But this also just kind of shows that you can put data from different data frames into the same figure, right? So we have the economic data, and then we have the two truth growth data. Okay, let me see, where are we at here? So let's say this looks great, but we can make it look even better. Okay, oops. All right, so let's do figure 2. GG arrange LP, GG arrange BXP, DP, and Ncol equals 2, and labels equals C, B, C, and row equals 2, labels equals A, figure 2. Okay, so what you're like, we just typed the same stuff. Okay, so notice though where we have a GG arrange within a GG arrange. And so the first GG arrange, we say have line plot, and then we say our next facet within there, we have box plot and dot plot. So if we print this out, error, oh, I'm missing a comma. And I had too many of these. Let's try this again. Well, what's going on here? We have the A, where's the B part? BXB, DP, NCol equals 2, nlabs equals C, nrows, nrow equals 2, labels equals A, GG arrange. Oh, I don't have one called box plot, do I? Oh no, I do have one called box plot. Box plot DP LP. Box plot DP. I wonder if it messed up. Let's see. There we go. I had a typo somewhere in there. So as you can see, we have our first facet plot, which was LP, and then we put another, which is our line up here, and then we put another facet in there. So this space got turned into 2 spaces. So then we have our box plot and our dot plot within there. So as you can see, it makes sense to kind of space this one out. Instead of having like all this empty white space, no need for that. It takes away from the graph, right? And this looks a lot better. Okay, all right. Okay, this looks really good, but you'll notice that there are 2 legends that are the same. So let's fix that. GG arrange BXP DP labels equals A B common legend equals true legend equals bottom. All right, let's try this. Okay. So it's just an example of using a common legend, right? So it's not going to be the same as this plot. We don't want to write all that again. But you can see now we have one legend on the bottom that says yellow is dose and yellow is 0.5, blue is 1. And so we don't have this issue where we don't need these 2 legends, right? We just need a color legend for one of them. All right. Lastly, we should export the plot. So these are all well and good, and you can save image as a PNG this by right clicking, but we can export it too. So GG export figure 2 file name equals facet figure dot PDF. So you can export it as a PDF. So there you go. We can also export multiple plots to a PDF. So if you do this, your plots will go into a PDF where each figure is on its own page, right? So you just do GD export BXP DP LP file name equals multi dot PDF. So I'm gonna run that one. And lastly, we can export to PDF with multiple pages and multiple columns. Oops, R. GG export, BXP, DP, LP, BXP, file name. I know I did BXP twice. test2.pdf, and row equals 2, and col equals 1. Okay. File. Let's see, where am I? It's in documents. Okay. Let's go to my documents quick. Modified. Okay, so test 2, as you can see, we have all of our figures, but they're not a single per page. They're kind of pushed together on a page. Multi, it's one per page, but they're kind of stretched funny, huh? So it's like, they're huge. And then the facet figure, we have the one per page. So that is how you go about creating facet plots, where you can put multiple plots into a single figure, which is nice because sometimes you have figure limits on how many figures you can submit for a paper, or sometimes you don't want to have usually a figure tells a story, right? And so sometimes multiple graphs complement each other in that story. So it's nice to put all those aspects onto one graph. Like if you're looking at from a molecular standpoint, say you're doing something with a gene, and you do an isolation of the gene, and you do RNA-seq, and then you do a Western blot to see if the protein's expressed. Well, those are all essentially the same, experiment. It's multiple parts of a longer experiment to get a piece of DNA, check for its expression, and check for its protein expression. Well, you could put those in independent figures, but it might be better to do your gel, your expression profiling, and your Western blot all in one figure as different facets. So it's a way to concisely tell your story. Without rambling too much, 22 minutes. I thought this would be a lot longer, so I sped through this one for you guys. If you're watching on YouTube, hit like, hit subscribe. There'll be still more to come. There's a lot of different things you can do with data products. We haven't even gotten into preliminary data analysis yet, or the shiny stuff, or anything like that. I think coming up we'll be doing some Plotly, so some interactive graphing. With that, thank you for watching, and I'll catch you in the next one.